Hello, my name is seanmccrobie, and this is my compiler that I'm presenting for the midterm. Here's my main file. This is basics2.cpp, and this is the 200 lines that I have thus far. Alright, to get into things, I'll show you my first file I started creating before I kind of had a deeper understanding of what was going on. I was just trying some basic things, implementing some structures, refamiliarizing myself with the CPP language. Here, I really didn't understand quite the limitations or exactly what was required when I was trying to implement the AST, which is why the file itself is clearly doesn't really do much, doesn't have much in it. It was just me kind of fooling around, trying to figure things out with what we learned in class in the beginning. Also, it was me trying to catch up and kind of understand how to implement the project at all. The biggest hurdle for me was kind of getting into the swing of things and kind of understanding where I should be going with it, what I should be doing with it, where to start it all, basically. And this is just kind of the first file that I did here. I won't spend too much time looking over it. It's just what I started with, and then I quickly moved on. Alright, so here is the main file. Currently, if you compile it, it does compile. Whoop, I have an error. We'll just get rid of that real quick. Save and then recompile, and I should have no errors. Yep. These are just the old counts I was using to test as I went along, as I was implementing the AST piece by piece and ensuring that the structures operated as I hoped they would. Currently, the output file, all it does is just do this. Just prints out the language. You can see that it has all the syntax, all the quotations. The let functions have the brackets that were included in the book. I just liked it because I thought it was a little neater. And this is kind of where I ended up with my ST. If I want to walk through the structures, my declarations, I'm using the namespace standard std, so I wouldn't have to repeatedly write it as I went down because I was using a lot of standard things like strings, vectors, and whatnot. The libraries I included are input output stream, string, vector, map, and iterator. We won't start with variable, we'll start with the R expression, struct, and descendants. So obviously I first started with the R expression. I'm using structs instead of classes just to keep everything public right now, so I don't have to worry about private accessors or making anything accessible, or I can always just print out what I want to see in the structs. It was helpful for debugging purposes. I could change it later on, but currently it's not really a big deal for what I've been trying to accomplish thus far. This way I can just always access an object's data types. I don't have to think about it too much and worry about it at all. Alright, so I added the virtual functions to string first, and I just did return fail to get rid of the warning because it was reaching the end of a non-void function and I kept getting a warning. And then I implemented this in all the descendant structs, which are our int, our read, our neg, our add, our ref, and our let. The two string functions are all pretty basic. If we look at the our int one, I just return this object's integer data file type data, and I print it out as a string. This is just going to helpful for what we accomplished over here, so I could print out and see that the AST was implemented properly and that the code looks like it should. And again, I did that with the rest of them, similar to how you did it on your Java example that you went over in class. Super helpful to walking through that. I definitely looked at the lecture a couple more times to kind of see how the file types worked, what the data needed to be, how I was passing things by pointers. Currently, I'm passing everything by pointers. I don't have any deconstructors, so I basically have memory leaks everywhere. I'm hopefully going to switch to smart pointers as soon as I finish my first compilation, as I write flat and kind of get things going. Then I'm going to look over smart pointers. I was scanning over it briefly, but I didn't want to just kind of skim it and put it in and ruin things just yet. I kind of just wanted to keep focusing on the project and keep pushing through. I can fix memory leaks later. After I did all these string functions, I started working on the evaluation functions. I use a vector of strings for the input for read. That way I have, those are right down here. Evaluator, so I have the eval function, which is going to create a map of variable pointers and integer, and the map itself is a pointer, just so I could pass it continuously between the functions. But for the numbers, I'm using this, and I just created a vector of strings, and I inputted a couple numbers so I could test read as I get through it. Back up top, or under our expression still. Again, I started inputting the virtual functions. These friend functions to the output stream are just so I could output things easily, not have to worry about referencing the data exactly. It just does it automatically and calls the toString function so that it prints out immediately. But going down, the eval function for our int we already went over. For read, I just implement the iterator for now. I know it's not optimal. I skipped the first number, but just to kind of get me through it so I can test some numbers and see what's going on. Our neg, I, again, just multiplied the expression after it evaluates and returns by -1 because all my terminals are currently just numbers. For our add, the evaluation function, again, gets handed all the same stuff. I just return the left expression, evaluate it in the right expression. Again, this is a lot of stuff that you went over in class. Here, the evaluator returns the environment at the addirect of the map. So to make sure that my map is functioning, I just used a basic map. I didn't implement one that the one you went over in class. I, again, just brought in the library and just created a basic map using the standard library so that I could get underway and kind of get more accomplished and see what I could do so I could write some tests quicker and see if everything was functioning as I hoped. Then the last one, definitely the most complicated one, I kind of broke it down the way you broke it down in class. I didn't want to leave it in the long form just so I can read it more easily in case I had to debug it, but it seemed to be working fine. I can run the test now. I'm just going to come down here. So now when I compile, I'm going to see the first couple of tests that I wrote. So for this one, I'm testing A, and A is all the way up here. It's in our int 10, so that was just the first basic test to make sure that my testing function was worked. So when it fails, it prints the actual number and then what we desired, and we desired 11 on the purposely failed test. I used these as little separators, and then I started to test my AST. So I tested 18 on alpha, which is pretty basic. Alpha's right here. It's just a simple addition between two integers. We wanted 18, and we got 18. Again, I just showed the failed to show that it detected when it failed. So when we desired 14, it failed and printed out the actual of 18. Third test was beta. I did an addition, and I just implemented a negation because I wanted to make sure the nesting was functioning fine, that the evaluators were recalling recursively properly. So down here, again, you can see the language, plus -8 and 10, success when we're looking for 2, that's the actual, and then it fails when you're looking for anything else. I just did 22. Last and final test is Charlie. It was just my let function, which is incorporated in the map, and Charlie did actually print out successfully as well. So I did let the x be 8, and then I added the x and 5 together, and you get 13. The actual is 13. And then when you request anything else, we requested 8 and it failed. Again, the language did print out properly and it evaluated properly too, so I'm extremely happy about that. The next couple things I'm going to work on are obviously the C language and then eventually down to the x86 so that I can fully compile basics. As for now, this is all I have. I'm glad it's up and running. It's about 200 lines, and I'm excited to keep going. I learned a lot, and hopefully I can clean it up soon. And other than that, there's not much more to go over. Thank you for your time, and enjoy the rest of your day.